Today we're going to talk about the North Carolina Standard 1.0A2. Represent and solve word problems that call for addition of three whole numbers whose sum is less than or equal to 20 by using objects, drawings, and equations with a symbol for the unknown number. The video focus is on two strategies, make a 10 and using doubles. The 10 frame is a great tool to begin with, especially with using the make a 10 strategy. So simply provide a problem something like this. I have 7 squares, 4 triangles, and 3 circles. How many shapes do I have? We want to begin with the concrete objects, and in this case you can actually have the objects in the problem, which is what some students might need at the beginning. So I'm going to use my shapes to solve my problem. I have 7 squares, I have 4 triangles, and I have 3 circles. So I can see that I have made a 10, and I have 4 more, 10, 11, 12, 13, 14, or I know that 10 and 4 more is 14. So what we want to move the student to is, after several experiences with making a 10, using a 10 frame, they can easily see, oh, I've got 7 filled in my 10 frame. I need 3 more to make a 10. I have 3 circles. There I can make my 10, and now when I add my 4 triangles, 10 and 4 make 14. So what you are actually teaching here is the associative property, which is not something they need to know the vocabulary for, but they do need to understand that when they're adding 3 or more numbers, it does not matter whether the first pair of numbers is added or if I start with another pair, like I did here with 7 and 3 to make a 10. So knowing this property can help children identify combinations of 10 from the numbers they are working with and know that they don't just have to add left to right. So then moving from the concrete, we want to move them into drawings. So now I can continue to use my 10 frame and know that I have 7 squares. I really don't need to count because I know there's 5 on the top and 2 more make 7. I need 3 more to fill my 10 frame. I'm going to use my 3 circles and then end with my 4 triangles to see that I have 14. What we would like to move the student to is writing the equation. So when I look at this problem, I know that 7 plus 4 plus 3 is going to be my equation. I'm going to use a box for the unknown. So once children have had many opportunities to make a 10 using a 10 frame, they're going to start to see the patterns and recognize when they've made a 10, or when they see the numbers and know, oh, I know these two make a 10. So the final stage is students recognizing that I know 7 and 3 make a 10, and then I'm going to add my 4 to make 14, which is the progression of what we would like to see them do. And by many experiences with 10 frames, they will start to recognize combinations of 10 without having to count on their fingers or use objects. So let's take a look at another problem that involves doubles. Miss Giddings has 6 jump ropes, 8 soccer balls, and 6 boxes of chalk. How many recess toys does she have for her class? So in this case, you may have a student or several students who know their doubles, so they're not going to need to build out this whole problem. They're easily going to say, oh, I know 6 and 6 is 12, and I need now to add my 8. So they may select to use manipulatives to count out 8, or they may draw out 8 circles and say 12, 13, 14, 15, 20, or 12 and count by ones until they get to 20, and they have their answer because they use doubles. We want them to move to writing the equation, something like this. I know my equation is 6 plus 8 plus 6 equals box. I already know my doubles. 6 plus 6 is 12, and I just have to add my 8. Be mindful of what a student does when they add that 8. Are they counting on by ones, or are they using what they know about 10 to solve this problem? So I have 12 plus 8. 8 and 2 make 10, and 10 plus 10 is 20. So the answer to my problem is 20. Students should have numerous experiences with concrete models and drawings before moving to equations.